Good afternoon, class. Thank you. You can take a seat. All right, then we've completed the exercise on areas and perimeters of different shapes. Now we are going to look at the surface area of solids. And then I'll give you an exercise to do. Okay, on the board I've got the the diagrams of the different solids that you are familiar with. All right, the first one, the surface area of a cube. Now, to find the surface area, what you have to do is find the area of all the surfaces, okay, of the solids. Now, for the cube, Margaret, how many surfaces does a cube have? Or how many faces does a cube have?
Six.
Six. Okay, if there are 6 surfaces, what is the surface area of a cube, or the formula for the surface area of a cube? Okay, if L and L.
Six L.
So
Squared.
6L, okay, 6L squared. We know that the cube has 6 faces. There's 1, 2 on the side, the front, and 1 at the back, the top and the bottom. So there are 6 faces. Each of them are squares, L times L. So the surface area of a cube is 6L squared. Okay, some books you might see S instead of L, but it means the same thing. Okay, the cuboid. All right, I have L, let's say B, and H. Peter Pomeliu, the surface area of a cuboid. How many faces does a cuboid have? 6, okay. 2 of each are the same. The front one is the same as the back, the sides are the same, the bottom is the same as the top one. So what is the surface area? Any other students who would like to answer this? Or who would like to give us the surface area of cuboid? Ponrele.
Two BH plus 2LB plus 2LH.
Okay, very good. There are 2 faces that have the area B times H. There are 2 faces with the area L times B, that's the bottom and the top. And there are 2 faces that have the area L times H, that's the front and the back one. Right, the sides B times H. Okay, next one, we go to the cylinder. The cylinder, you all know what a cylinder looks like, the famous tin of fish that you eat. That it's contained in a can, which is a cylinder. Okay, the cylinder is, if it's closed, then you will have these 2 circular ends at the top and the bottom, and then you have the body as well. when we talk about the surface area of a cylinder, then we are talking about the surface area of a closed cylinder. If you ask for an open one, then you'll have to think a little bit before you do any question based on that. Okay, if I get this piece of paper and I held it to you like this, then that's a cylinder, but it's an open one. Now, if it's cut, or if I open it again, it actually becomes a rectangle. All right, so this will represent that. Sorry, let me just turn it so that it's a different color. Okay, the body is represented by that plus the two circular ends. Okay, so what is the surface area of a cylinder, knowing that it has a radius of r and a height of h? There are two, I've actually drawn the nets here. You've drawn nets in lower grades, so grades 9 and 10. So I want you to tell me the formula for the surface area of a cylinder. Rita?
Two pi r times r plus h.
Okay, 2 pi r times
r plus h in brackets.
okay, r plus h in brackets. It comes from 2 pi r squared plus 2 pi r h, where 2 pi r squared represents the two circular ends. And because this is a rectangle, the length is 2 pi r, which is the circumference of the top and bottom end of the cylinder, and then h is actually the width of the rectangle. So that's where you get 2 pi r times r plus h from. There are again, it's made up of two circular ends and a rectangle. Okay, then we go to the cone. You've all eaten ice cream, so you know what a cone looks like. All right, except again, this one is a closed cone. It has a perpendicular height denoted with letter H, and it has a slant height, which I always denote with a letter L. In many books, they also use the word S to mean slant height. Then the radius here, which is R. Now, I drew the net of the cone as that. If you actually get a cone and then cut it, you will end up with this, and then if you remove the circular end, you will have a circular end here. Okay. You have to give me the formula for the surface area of a cone, and you have to explain how you got that. Okay, first it's made up of a circular end. So what is the area of the circular end? Esther?
Pi r squared.
Pi r squared. It's just a circle, so pi r squared. Plus, what is the area of this? Anyone? Siegfried? What is the area of this? Or what does it look like to you? A sector of a circle. Okay, how do you find the area of a sector of a circle, Siegfried, from our previous lessons?
Pi r squared times given angle over 360.
Okay, pi r squared times the given angle over 360. Okay, I just want to prove to you the other part of the surface area of cone and why it is written that way. If I had an angle theta here. Okay, just have a look to this side. Then the area of that would be theta on 360, like Siegfried said, the area of this would be theta on 360 multiplied by pi r squared. In this case, you can see that what I've done is I've given you the arc length, which is actually 2 pi r. It's same as the circumference of the secular end, right? It's 2 pi r, and this one is the radius, and so if I were to first of all find the arc length, then the arc length is actually given by 2 pi r. In a previous lesson, you were also told how you can calculate the arc length, and each part, the given angle multiplied by 360 and part of the circumference of a circle. Now, what would be the arc length if this one was theta and this one was L? Okay, forgetting this one first. This one we know it's from the circumference of a circle, but if it was not there, how would you calculate it given that this is theta and this is L? Kila. The question is, if you didn't know that this arc length is 2 pi r, we know that it's 2 pi r because it's the same as the circumference of the circle. But if it was not there, and you were asked to calculate it knowing that this is the angle given, theta, and the radius is L, what would the arc length be? Theta over 360
Times L.
times
L.
YL. L is the radius, so you cannot say theta over 360 times L to give you the arc length. Okay, it's just the arc. If this was not there and you were asked to find this length, given that this is theta and this is the radius is L. Boromeo. It's not hard, come on. An arc length is part of a circumference of a circle. So what's the circumference of that sector? Or what's the arc length of that sector given that the circumference of a circle when r is L? Okay, what would be the circumference of this circle if it had a radius of L? What would be the circumference of this circle if the radius was L and not R? 2 pi L. So why is it taking so long? 2 pi L. I said, what is the arc length? If you didn't know that it's 2 pi R, how would you find this arc length if this is theta and the radius is L? It is part of the circumference of a circle. Okay. If I divide 2 pi L on both sides of the equation here, I will get 2 pi R over 2 pi L. This and this will cancel out and I get R over L is equal to theta on 360. So if I divided the radius by L, it will be exactly the same as the angle divided by 360. Now what I'm trying to do here is to show you where the other part of the surface area of a cone comes from, because some of you know that it's pi RL, but you never know where it's from. Okay, the area of the sector here, knowing that this is R, will be theta on 360 times pi L squared. Are you with me? Okay, we are trying to find out what the total surface area of a cone is. It's pi r squared plus the area of this sector, which is, okay, I'm going to do it here so I can just put it there. The area of the sector is theta on 360 multiplied by pi L squared, because L is actually the radius of that sector. This 2 pi r is the arc length. Okay, so I get theta on 360, we found out that it's r over L. We've used this to find that theta over 360 is actually the same as r over L. So if I replace theta over 360 by r over L, I will get pi L squared. Okay, theta over 360, which is the same as r over L, of part of a, it's part of a whole circle. So I now get pi r L, because L and one of these L will cancel out, and I multiply pi L by r, and I get pi r L. In your textbook, it might be S. I don't know what it is. But if, so in some books, L is represented by S. So the area of this sector of a circle, if you've never known where it comes from, this is where it comes from. Because some people, they just know that the area of this is pi r L, but they don't know where pi r L comes from. At least I've told you. So that's where the surface area of a cone comes from. It's the circular end plus pi r L, which is the area of the sector. Okay, I've just proven to you that it's pi r L. Is that clear? Okay, when I gave an assignment last year to the grade 11s, they actually had to prove this. They had to prove where they got the surface area of a cone from. Sometimes, you know, you've got to know where the formulas come from. Okay, for the sphere, the surface area is 4 pi r squared. When you do calculus in grade 12, I am going to tell you where this comes from, 4 pi r squared, because if I explain it to you, you will not understand it. So I'll show you next year in grade 12, if I'm here. Okay. Your job is to find the surface area of this solid. You do it as an example. Quick, I'm going to give you 5 minutes. Okay, sorry, before you do that, one more. Sorry, just wait. I forgot about this. The pyramid, depending on the base of the pyramid, because you can have a square base pyramid, you can have a rectangular base pyramid, you can also have a triangular base pyramid. Depending on the base of the pyramid, usually the perpendicular height is always denoted with the letter H. Okay, if this is a rectangular base pyramid, then all you have to do is to calculate all the surfaces, all the areas of all the surfaces of a pyramid. So this one will include the area of the base, which is a rectangular one. Then you will have 1, 2 at the back, 3 on the side, and 4 in front. There are 4 other faces that you will have to calculate their areas. So for the surface area of a pyramid, I just say the area or the total area of all the surfaces, because the pyramid is of all areas of the surfaces or faces. Okay, you have to do this question now. 5 minutes. you see that there is a measurement which is a multiple of 7, use 22 on 7. Okay, note the surface area of a cone in the book that you've got is for an open cone, in case you get that mixed up. Where did you get this one from? Is it pi r squared? Pi r squared plus 2. You have to note that that circular end in the middle is not on the surface, it's inside. So you can't separate that one. You get the bottom one and the cone, but it will only be the sector and then the body of the cylinder. Pi r n plus pi r squared plus pi dh. What's d? Oh, okay. Finished? Okay, the figure is actually made up of a cone which is on top of a cylinder. Note, the surface area will include the area of the base, which is a circle, the area of the body of the cylinder, which is the curved surface, and then this one is inside, so it's not on the surface, so you cannot calculate the area of this, and then the area of it will be a sector of a circle. Okay, so the total surface area is going to be pi r squared plus pi r L, right, which is the top part, and then plus 2 pi r h. Okay, which is, I'm just going to factorize this to make it easy. All right, I can see that I've got a common factor of pi r, that's r plus L plus 2h, just so that it's easy to substitute. Okay, what I do is, if I see that there is length, a dimension which is which has a number which is a multiple of 7, I just use 22 over 7. All right, if it is a different number, then I use 3.1 for that. Is if I'm not right, it's easier that way. So 22 on 7 times the radius is 7. 7 plus L is 10 and H is 20. So I get 22 times 7 plus 10 is 17. 17 plus 40 is it 57? 7 plus 10, 17 plus 40 is 57. Okay, 57 times 22. 5, 1, 5, 1, 2, 5, 4, and that's centimeter squared. All right, you do question A, exercise 3, 1A. That's a pyramid. That's a pyramid. But it doesn't have the height. What is it? I can't tell. Oh, okay, the figure is it's a pyramid with it's actually got a square base. That's 6, 6, 6, and 6 on that side. This is the height, the perpendicular height. So it has faces, the front face, this one, there's a face at the back, and there's a face on the side. Okay, we'll say that this is the faces are equilateral triangles. So that means if this is 6, that's 6, and this is also 6. The 4 faces which are equilateral triangles plus the square base. Doesn't look like it, but it is. Oh, is it a triangular base? Where's the base? One, two, three, four. No, it's not. If it's a triangular base, where is the base? Is it this one here? Okay, 6, 6. Okay, we'll have to get this right so that you can do it correctly. Okay, if this is the base, actually it looks to me like a square base, but if this is the base, then there's one face, there's another one, and there's another one at the back. Okay, so it's a triangular base. 6 and 6, and this one is also 6. So the faces are equilateral triangles. Okay, see if you can do that one quickly before you go. The base is 6, 6, and 6. The faces are also 6 centimeters each. You don't need the perpendicular height for the surface area. You can work out the height of each of the, using Pythagoras theorem. You are not thinking. There are 4 faces that are exactly the same. That's what I thought at first, the way it's drawn. Yeah, that's what I thought at first. I'm not very good at perspective drawing, so I always have problems with this. So as some solid trick. No, it's a triangular. We just get it as a triangular pyramid. The base is that so there are 4 faces that are exactly the same. What? Which height? The perpendicular height for each of the faces. Yeah. Are we done? All you need to do is find, this one takes a very short time. All you need to do is find the area of one face and multiply it by 4. There are 4 faces that are exactly the same. So area is equal to, first you need, because it's not they are not right angle triangles, you need to find the perpendicular height for each of the face, which is exactly the same. So if you were to find the perpendicular height of this in an equilateral triangle, this should be 3 and 3. Okay, the other side is 6. So first of all, to find the height, you will get 6 squared minus 3 squared. The square root of that, and you get 36 minus 9. 36 minus 9 is equal to 27. What's the square root of 27? 5.2 decimal place. Okay, so the area is equal to half of the base is 6, the perpendicular height is 5.2 when you multiply it by 4. The answer is, Solomon? 62.4. Okay, for homework, you are going to do all the questions. That's question 1, B, C, 2A, B, C, D, E, F, 3, 4. Oh, only 4 questions. I was thinking there was 10. All right, the keyword to the pilot teacher is surface. Good afternoon, class. Good afternoon, Mrs. Thank you.